సార్ కోహోస్ట్ ఇచ్చేసాను.
Okay, okay. I got it. Okay, got it. Okay, good evening to everyone.
Yeah,
So-
Ravi sir, YouTube start చేసి
స్టార్టెడ్ ఆల్రెడీ.
యూట్యూబ్ స్టార్ట్. ఓకే దెన్ ఇప్పుడు హోస్ట్ కూడా రవికి మన విక్రమ్కి ఇచ్చే ఎగ్జిట్ అయిపోయి నేను కూడా ఎగ్జిట్ అయిపోయి.
కోహోస్ట్ ఇచ్చేసాను. హోస్ట్ కూడా ఇచ్చేయమంటారా సార్? ఎస్ సార్, డన్.
Okay, thank you. Okay, shall we start the class? Like today we are here to discuss about the agrometeorology topic and its introduction. And is everyone ready to? Okay, can we start the class? Like Madhavi and Manaratnam, everyone is ready.
Yes, sir.
Okay, and you people are reading agrometeorology from which book you are reading? You are reading from SRD or you are reading from Reading Ready for the JRF?
Ready and ready, sir.
But I feel we need to prefer SRD for the meteorology topic because they are given very vastly in the meteorology. And since last 3 years they are asking from the SRD only most of the questions like wind speed meter and ilmograph, like that. Some bits they are asking from the SRD, especially the recent editions they are asking. So better to read once again from the SRD. So first of all, what is the weather and what is the climate? Anyone can explain, like, is a basic difference between climate and weather.
Weather is at a given
Simple,
place
simple.
and given time.
No,
Climate is vast area.
vast area with a long term. It's like climate is related with is a long term data. They will pull it and they will make some climatic data like that. Like they will make is a long term and large area they will talk. But weather is all about the small area at the time, exact time what is happening in the area. That is like weather. So now we will start. First of all, what is a meteorology? So directly I'm going like in India, which institute is studying about meteorology related? IMD, right? Indian Meteorological Division. And where it is located?
Pune.
Not Pune, that is in Delhi. Mausan Bhavan, Delhi. Is a Pune is like in the earlier days they started in Pune, but nowadays like since 1950 onwards it is located in the New Delhi. That is the Mausan Bhavan. So we have to make that correction that IMD is located in here. Indian or India? IMD means I.
India.
India, yes. That's one more. There, like so many people will make that's Indian Meteorological, that's India Meteorological Division. And under which ministry that IMD will comes under? Ministry of Earth Sciences. It's not from agriculture side or from any side. It is the Ministry of Earth Sciences is a body of the like it will comes under the Ministry of Earth Sciences. IMD comes under. And in which year IMD is established? In which year IMD is established? Like I'm asking just general bits because we don't know like how they will ask questions also. In 1875, that is established in India. But they started agriculture meteorology in the 1932 to related to agriculture meteorology topics, and like they will study related to the this one. So we will start with the first of all, what is a meteorology? Meteorology is a Greek word. It is consists of two words. That is meteos plus logia. Means meteorology is nothing but high in the sky. Like in the sky, what is happening and what is a relation between the air and the temperatures and the solar radiation. And what is happening in the atmosphere. This study is known as the meteorology. It is nothing but physics of the weather phenomenon. Like what is the physical happenings is going on in the atmosphere is known as the meteorology. And what is the agriculture meteorology is this physical phenomenon is related to the crop development is known as the agriculture meteorology or agrometeorology. So why is agriculture like agri-meteorology is important for the agronomy people? What is the need? So anyone can like guess what is the reason behind agronomy people are need to know about the agrometeorology and what is the dependence of agrometeorology in agriculture. So what is the basic like if people can tell what is the relation between agriculture and meteorology? Why it is need to be studied?
Study of weather related to agriculture for
That is
increasing
okay.
crop production.
What is the reason behind it? Like why we have to study this one? Like we're having water also in area, but why we have to read, especially for the agrometeorology, we have to read not about the hydrosphere. Like we are not reading about the water related sea, or we are not reading that one, but just we are reading the air phenomenon or physical phenomena of the atmosphere. We are reading. Why? What is the reason to read in agriculture as the agrometeorology subject? Because our production is completely based upon the environment, because around two-thirds of productivity or definite like productivity is based upon the weather. Like our Indian agriculture or entire the global agriculture is completely dependent upon the weather elements like rainfall, pressure or winds or monsoon. So we are dependent upon these areas. So we have to know about the weather phenomenon, how it is occurring, and what is the relation between the monsoon and what is the relation between the air pressure over the sea, and this relation has to be studied. So that's why the agrometeorology is important to the agricultural production. So entirely the yield of the crop is completely based upon the weather phenomena in the area. So at least 2/3 of the yield productivity are getting from the weather parameters. Like for example, if you are having good fertile land and everything, but weather is not supportive, so what will you get? You will get around yield loss will be done, because when you people are don't having the rain, so how will you sow the crop and how will it will give its potential productivity? So the agriculture is completely based upon the weather element. So it's need to be studied the agrometeorology. Like we already know that the genetic potential of the any variety or any seed has to be generated with help of the like will perform under better under the good environment as well as the good genetic purity. So this environment plays a major role in the productivity. So we have to know about this agriculture meteorology. And what is a microclimate and a macroclimate? Microclimate is nothing but that is micro means small, climate means in that particular area we have in the long term. So that is microclimate means in the small area at a height of 2 meter of height. So what is the effect of microclimate? Like for example, if you are having plenty of trees in your backyard, so you will get the coolness when compared to the adjacent areas. So that is, so what is a climatic effect, or what is a weather changes that occurs in the place is known as the microclimate. Especially in agriculture fields, we are having more number of trees or more number of vegetation, so the temperature automatically reduces. So this has to be studied as known as the microclimate, and microclimate is like it's a very large area we are going to study, like without vegetation and without any plants. So that is a microclimate. So here first we will study about the agrometeorology. In that agrometeorology, first we will start the layers of the atmosphere, like how these layers has been differentiated and how many layers in the atmosphere is located. Anyone can tell, like troposphere, stratosphere is there, right? Like that, how many layers are there in the atmosphere? Majorly.
5 layers.
Actually, there is a contradiction topic. Like in SRD, they given about 5 layers, but in ready and ready, they given it 4 layers only. Right? Troposphere, stratosphere, and thermosphere and ionosphere. Like this is only be given. So and this layers has been divided into 4 layers majorly, and 5 layers also there. But ionosphere, like above ionosphere, like exosphere is there. That is not related to the atmosphere, because around 99% of the area, like in the atmosphere, is comes under this area only. Like what we have to study weather phenomena, it comes under only these 4 layers. Above after 100 kilometers, there is no effect on our weather phenomena. So we have to tell the majorly 4, but if you take everything into consideration, it has to be the 5 exosphere. And these layers divided on the which basis they divided, and the which basis they divided. That is also important.
Height. Height, sir, altitude.
Not about the height here. The thing is about the temperature variations, the vertical temperatures. If you see the troposphere level, so gradually the temperatures will be reduces. In the next layer, stratosphere, temperatures will be increases. Then again in the thermosphere, the temperature has again will be reduces. But ionosphere again temperatures will be increases. Like the based on the weather, like in the vertical temperature of the height. So we divide into the four layers. So in between these layers, one pause area will be there. That is known as, like for example, troposphere and stratosphere. The layer is tropopause, stratopause, thermopause. It will be there. These pause areas will be like it's a middle area. So then coming to the first layer, that is a troposphere. The troposphere is also known as the sphere of the weather phenomenon. Like all the weather related activities occurs here only because 85% of the atmospheric actions takes place in the tropospheric region. So this sphere, like this region, is known as the place for the weather phenomenon, like weather occurrences. Then, like that, what is the stratosphere mean? So, what happens in the stratosphere, and what is the most significant thing happens in the stratosphere is that we have the O3, that is ozone layer. So it will absorb the UV radiation from the sun. It will protect the people from the UV radiation. So in this region, the temperatures will be more because the O3 layer absorbs the temperature from the sun UV radiation. So the temperatures will be higher in this region. So it is known as the photochemical zone. Photochemical zone. Then above thermosphere will be there and above ionosphere. In this ionosphere, the radiations will be radiator waves. Like we will get all the satellites and everything, the information and microwave propagation and everything done in this for ionosphere. So in this, like you people has to know about this layers as well as their importance and what is related, what is the significance of this layers to the people, right? So this is about the terminology related to the atmosphere. Then we will go about different observatories are also there in place. So how many observatories are there? Observatories are two types. That is the meteorological observatory and agrometeorology. The meteorology is related with only meteorological terms and the meteorological indicators they will study. But in agrometeorology, that's crop related activities they will take care. Again, this agrometeorology are again five types based on they are giving information. They are having the like for example, A observatory they will give around every day they will give the observations, and in the B observatory they will give around 3 days onwards. Like that, the observatories will be changing the information. Like they will give the information to the farmers based on the information given per day. Like they will do like that. So based on that one, and these observatories are also having infrastructure differences also. Like A type will having the principal agrometeorology. So all the weather parameter related instruments will be there. So it will have it will collaborate with the different international organizations and it will publish the weather data in a long-term basis and everything. It's is a and they will prepare agroclimatic atlas of the India and different regions also they will publish. And then coming to the B type, that is the ordinary agrometeorology observatories, and they studies the minimum generally what we will study. So that is a rainfall and air temperature, humidity, soil moisture, and pan operation studies they will do. So that is the B type. Like in the generally in the research stations and in the district headquarters, these B type of observatories are there. This is a basic observatories related to agriculture. So that is a B type. And then coming to the C type is auxiliary agrometeorology. Means auxiliary means is related to the qualitative data of pest and pest attack. So these will studies about like what is the pest relations and what is the temperature effect on the pest and how it will be generated and how relative humidity affects the pest population, like the studies, and they will give the training to the field officers and they will give you some observation periodical periodical inspection of the observatories for the advices and the corrections. So they will give some inputs to the farmers as well as the who are in the agriculture department. They will provide the data. And the D type and E type are the micro stations. Especially this is for the like desert locust control and so like that they will have. And E type is only for evaporation transpiration stations, like different locations, especially in the arid regions. We has to know about the how much of evaporation takes taken place from certain area. So this type of observatories they will locate it, but most of the agriculture universities and district headquarters are having the B type of observatories. And what is the like I'm asking the question, and what is the minimum area required for the agro observatories? So what is the area? Like I will give the options like uh, 55 into 37 or 40 into 60 or 80 into 40 like that. So what is the
40 into 60.
40 into 60 basically? But exactly if we want to do this B type of agrometeorology like agro observatory, we need around 54.86 into 36.58 means 37 into 55. They has to know like and which phase we have to show like in which side of face should be located. It is a north face or south face or which face we have to take. Which face? Which face it has to be take? It has to be the east faced one. The observatory should be in the east face side. Then you will get the all observations in a good manner. And what is precautions to be taken in agrometeorology? Like agrometeorological observatory means in the nearby area around 50 meters of area, no vegetation should be there. No vegetation means no tree should be there and no building should be there. Like what happens if the trees or buildings are be located near the agro observatory? What is the possible problems and what is the why it should not be there these objects? What happens if these objects are there nearby the agro meteorology observatory and what is the problems is posed? Right, you know, right, that is microclimatic variations will be there. For example, if having any larger buildings, so the shadow will be occurs on the instruments of the agrometeorology, so automatically there is a variation. Even if we are having the vegetation in the agrometeorology observatory location, so automatically the transpiration will occur and the evaporation losses will be it will be reduced because the covering of the land will be there. So the evaporation losses will be not exactly calculated. So in that agrometeo, like in the observatory areas, the vegetation should not be there and it should be in the bare soil and no like high-rise buildings or no tree should be there, should not be there in the nearby areas of the the site of the observatory. So these are the some of the precautions and they have to take like here what are the instruments generally they will use in agrometeorology? Any one of you people can tell. Basic instrument they will use in agrometeorology. If people are anyone seen the agrometeorology observatories? Anyone seen?
Yes, sir.
So from where you seen?
Rain gauge, fan evaporimeter, sunshine recorder
What is the use of the rain gauge?
for recording rainfall, amount of rainfall, per day.
Per day. So what is a rainy day? If you are calculating in a rainy day, like in so what is a rainy day?
Greater than 2 mm.
Greater than 2 or greater than 2.5 mm?
2.5.
Good. Greater than 2.5 is known as a rainy day, and here you have to know like what the instrument they will use, like what is the chemical they used in alcohol, where they will use, where they will use mercury, and like in the minimum temperature, what the content there, what chemical they used for the measurement of the temperature. Alcohol they will use, right? Like what is the maximum temperature and what is a dry well and what is how the functions works. What is a wet well? What is a wet well? That is what is the significance of wet bulb and dry well, and what is the relation with like what they will do, like how they will predict the weather with help of the wet bulb and dry bulb. Knows anyone? Kalyani? So the wet bulb and the dry bulb, they used for the relative studies, like relative humidity studies. So we can be used. So in the wet bulb, what happens is we will have the plug or some any the cloth material should be tagged at the end of the thermometer, and that the end has to be in the water. So when the water is evaporating from the tag, like that is a cloth, so the water has to be the moist. So with the help of this one, you can measure the temperature of the area. So with that one, you can measure the hygroscopicity, like that is what relative humidity you can calculate. And soil thermometer is also you can use for the soil temperature. And wind vane is for the wind direction, anemometer for the wind velocity. Here hygroscopometer with help of the inside the room, like you can calculate the relative humidity. When relative humidity you can calculate when the hair is uh, straightened, like in the hard, that is in the lower saturation levels, like that. Some indicators are there. You have to see that one also, and the psychrometry for the relative humidity, and the barograph for the atmospheric pressure for the continuously, and helograph, the duration of the bright sunshine hours, and sun durations can be calculated with the or that one sunshine recorder will be there. Sunshine recorder, and so like this, different instruments are there. They use in agrometeorology. You people has to know. So all instruments, and what is the height of the, like all the heights also, like wind vane height and anemometer height, Stevenson screen. What is the use of Stevenson screen meter? Like what you will calculate is with the help of that one you can calculate the minimum and maximum temperature as well as the relative humidity you can calculate with the help of the Stevenson screen, and rain gauge will be there, and what is the height from the surface. So for example, Stevenson screen will be at the height of 1.22 meters, 1.22 meters, and the microclimatic post is around 3.68 meters, and sunshine recorder around 3.08, and moment is also at the height of 3.08, because this has to be exactly taken, because if the air velocity or wind direction this has to be in the above 3 meters, it will be normal, because above 3 meters means the plant canopy will be not be there, so there is no effect on the this there is no effect of the trees on the wind direction as well as the wind speed calculation. So they has to be in a certain height. Even in the rain gauge also, there has to be around the at the height of 75 centimeters of height. That is automatic rain gauge. If you are taking the rain gauge is ordinary type, then at least should be in 30 centimeters of height. So even like the even USB fan hygrometer, it has to be in a certain height, that 25 centimeters of height above the ground level. And what is all these instruments are height from the weather has to be taken care, and they should be in the exact height. And what is the color of the Stevenson screen? This is a white color, because the white is having a peculiar quality that it can be emit the radiation outside. I mean, it won't absorb the radiation. It is having a high albedo, so whatever the energy like from coming from the sun has to be exited outside. So there is no effect of light on the instruments present inside the Stevenson screen. So automatically there will be no effect. So there is no effect on that one. So what are the readings coming from that one? It should be perfect. Like it will be perfect. So these are, it is a major significance of the color of the Stevenson screen. And what are the units also important? In the agrometeorology, the temperature will be measured in the centigrade, not in the Fahrenheit or not in the Kelvin. This is a universal measurement they will take. And the relative humidity, like in the Hg they will use, and in the percentage relative humidity. Vapor pressure is MM of Hg, that is the mercury level. Wind direction is according to the degrees of direction, and they will tell according to the north. From the north side they will tell, and the wind speed kilometer per hour, and the rainfall is mm per day, and the broad sunshine hours in the hours, and the cloud cover is in the octave, and atmosphere is in the millibars per mm of the Pascal. Like that they will measure. And what is the if temperature is equal over a period of area, like is having the equal temperature for a period of line, period of area, like period of a place, like the location, These known as the isotherms. And what is isotherms and what is the isohills? What is isohills? The similar sunshine duration is known as the isohills, and isohills is similar rainfall over a particular location. If the we will draw a line over a particular area with help of the same rainfall is known as the iso heights. Isonomals mean thermal anomalies, like some difference in the temperature is known as the thermal anomalies. And what is thermoisoplate is soil temperature. Thermoisoplate is soil temperature. What is the height of the troposphere?
8 to 18 kilometers.
Yes. Mm.
50.
In like it will be varies at the equator region, and it will varies at the poles region. In the poles, it is around 7 kilometers, 7 to 8 kilometers, and in the pole region, it will be in the 17 kilometers, like in the equator region. So this is a variation. And what is the temperature in the tropopause? It is around minus 60 will be there. That is a tropopause. Like as I told in earlier that if you are going by height in the troposphere, the temperature will be reduced. So when you are reaching the tropopause, that is around 18 kilometer above the land surface in the equator region, so you will get the temperature of minus 60. So it will be that much of cool. Then again, but you won't feel that coolness because in the daytime, what happens in the sun will be there. So sun rays will fall on the earth, so you won't feel the minus 60 degrees centigrade. And most of the clouds will be occurs in the troposphere only. So that's why you won't feel the temperature and by minus 60 degrees centigrade. And after that, in the after the tropopause, again the stratosphere will start. In that again the temperatures will be rises. And what is the height of the stratosphere is 50 kilometers, and thermosphere is 50 to 80. Then above ionosphere is above 80 to 120, or up to the exosphere. These are the layers of the atmosphere. And what is 5 degree? You know the doldrums, low pressure zones, doldrums.
Yes, sir. 5 degree north and south.
That is a doldrums. What is a 41? These are having different names. 40 is having certain name, 50 is having certain name. Some certain name should be there. When horse latitude.
Horse latitude 30 to 35 degrees north and south.
Roaring 40s between like western winds, that area, not doldrums. This is known as western. Like only you are there. Too many people are exited. I don't know why. What's the problem also? I don't know. So at what height of the and like here I'll ask one bit, and which weather parameter is not having any effect on crop productivity, but we will take into consideration in agrometeorological studies. So which parameter is not having any effect on the crop, but we will take into consideration for the class, so like for the weather studies. What is that weather parameter? Like I will give the options. That is humidity, and B, atmospheric pressure, C, sunshine duration, D, temperature. Which parameter is not having any effect on the crop, but we will take into consideration for the weather study?
Pressure, sir. Atmospheric pressure.
Pressure. We don't have any effect on, like the atmospheric pressure is not having any effect on the crop, even though, but we will study actively about the atmospheric pressure. And so, and how we will measure the air pressure? that is barometer we will use, and we have certain different barometer. There is a 14 barometer or aneroid barometer or a barograph, or and generally we will use aneroid barometer for these studies. And nowadays we are using barograph for what is a barograph? Barograph is continuously without intervention of the people. It will study 24 hours basically. It will make a graph about the air pressure, like air pressure over a certain period of the time, and it will run on the graph sheet. It is known as a bar graph. So it is a 24 hours work done it will do. And what is a 1 millibar equal to how many? Like 1 bar equal to how many? One 1 Pascal equal to how many millibars? Hello?
I don't know, sir.
You don't know the basic one. 1 Pascal equal to 1013 millibars. There is a basic, no? There is a basic one. 1 atmosphere pressure equal to and 1013 millibars and 76 centimeters. So that is the most one, and we have to see this one also. Like what is the inch in inches also? That is a 29.92 inches is 1 atmospheric pressure. And how many dynes is 10 to the power of 6 dynes per centimeter square. And what is the standard unit of atmospheric pressure is Pascal. 1 minute. So this is about atmospheric pressure. And how we will study about the wind direction? With help of which instrument we will study the wind?
Wind
Wind.
vane.
Wind vane is for the direction and wind speed for?
Wind.
So many people are from this BA 2020. I mean these people are from first year. Suprasa? But I don't know. So how many people are there from first year?
Sir, first year, sir.
And how many people are there? Like around so many people are joining in the class now. This is entirely from first year of Babatla.
11 people out of 14 are from first year, sir.
Okay. So you people know about agrometeorology or you don't know about agrometeorology? You completed basics of agronomy in your undergraduation course, but not taught. So now we will study about weather elements, and these weather elements are divided into 5 to 6, like 6 to 7 elements. That is, first of all, we'll study about the solar radiation. Like, what is the solar radiation? The radiation which is generated from the sun is known as the solar radiation, and the sun supplies the around like entire energy of the earth. Like, with help of the solar sun only we are getting all the energy. So around 100% of energy in the atmosphere, like on the atmosphere or in the earth, is completely from the sun. So we are solely depend upon the sun. So this energy is known as the solar radiation. And how much of solar radiation falling in an area per centimeter, in a centimeter square of the area per 1 minute, is known as the solar constant. Okay, this solar constant is also known as the Einstein units. It is also known as the Einstein units. There is nothing but amount of energy, solar energy falling in a certain area, in a centimeter square of the area for a minute. This is known as the solar constant, and this is also known as the Einstein unit. And this energy is in the form of, reaches to the earth in the form of the electromagnetic waves. And these particles are also known as the photons or quanta. So one solar constant equal to 1.94 calories per centimeter square over minute is known as the solar constant. Right, this is known as the solar constant. And what is the forms of solar radiation? Like, we are getting energy from the sun, and how many types it will be? So solar radiation, no, we can divide the solar radiation into 3 types. That is a direct solar radiation or indirect solar radiation. That is a diffuse solar radiation, and middle one is a global radiation. So direct radiation is radiation received directly from the sun by the surface of, like by the surface, is known as the incidental radiation. There is nothing but direct solar radiation. Then diffuse radiation means with help of the particles, the suspended particles, what happens, the radiation will be scattered. This is known as the diffuse radiation. So there is a difference in the difference between the direct solar radiation and the diffuse radiation. Most of the plants get benefited from the diffuse radiation, because in the mornings and evening, that we are, whatever the energy we are getting from the sun, it will be in the diffuse radiation. So the plants and the people get more energy from the diffuse radiation. So around in the diffuse radiation, around 0.65% means 65% of the light can be used for a photosynthesis activity. But in the direct radiation, we can use around 42% of the solar radiation can be used for the photosynthetic activities. So photosynthetically active radiation more in the diffuse radiation when compared to the direct radiation. So this is one more important bit for the JRF studies. So every year they are asking what is the photosynthetically active radiation in the diffuse radiation is around 0.65, that is 65%. So people has to know, like, what is the percentage of the radiation in photosynthetic active radiation is around 65% in the diffuse radiation, and what is the direct radiation is 0.42. This is known as direct radiation. And what is the global radiation? It is a mix of the both. That is how much amount of the solar energy is getting both from the direct radiation as well as the diffuse solar radiation is known as the global radiation. What is the amount of photosynthetically active radiation in the global radiation is 50%. So these are the 3 important bits is related to the this solar radiation. And what is the units and its conversions also? It's more important. It is like, for example, as already told, one solar constant equal to 1.94 or 2 calorie per centimeter square per minute. It is known as the solar constant, and it can be converted equal to one solar constant equal to 1353.92 watt per meter square per minute. This is known as the solar constant in a different units. These units also very important. And how this, what I told, the radiation is received from the sun into the earth in the form of the shortwave radiation, but the earth will reflect this radiation into atmosphere with the help of, like, in the form of the long wave radiation. Right, you know, right, this is the difference between shortwave radiation and a long wave radiation. Shortwave radiation is, it will incident on the atmosphere, but the long wave radiation means re-radiates, means it gets back to the return back, like light will fall on the earth and it will be known as the direct radiation. Like, that is a shortwave radiation in the form of the short waves, it will propagate. But in the reflect radiation, it will goes back to the atmosphere in the long wave. That's why we will feel the heat in the atmosphere after the some time. So here, when we will study the, like, I will tell you in the later, and here we have different instruments for the studies of the solar radiation, that is pyrometer or pyroheliometer or albedometer, net radiometer, quantum sensors are there, or different are there. Like, pyroheliometer is used for the direct solar radiation, pyrometer is used for the total incoming radiation. So these are different instruments are there to study the solar radiation. So are people are getting, like, so what is the percentage of the photosynthetic active radiation in the direct radiation?
2 to 10% are
42%.
photosynthetic active radiation.
Not 2 to 2, that is a 42%. 42% in the direct radiation. Okay, 65% is a diffuse radiation. So this is these three which are very most important. And what is a pyroheliometer and a pyronometer and how it is works, and what is the significance of the pyroheliometer. Pyroheliometer is having direct solar radiation, but pyronometer is having incoming entire incidental radiation, complete total incoming radiation in the form of the diffuse radiation. Everything they will take into consideration is pyronometer. So this people has to know, and what is the amount of radiation. But the thing is, how much intensity we don't know. Like, here we can know that how much of radiation is coming, we can study, but not intensity studies we can't do. So many people are there. And what is the infrared thermometer? Like, infrared thermometer is an instrument nowadays. Like, if people are known about COVID-19, and if people are seeing in any hospital or any movie theater, if you are going, they are screening your body temperature with help of infrared thermometer. It is nothing but it is a senses the temperature with help of the like, without touching the plant also you can access the temperature of the air temperature of the plant. So that is an infrared thermometer, and it is in the very narrow wave band, that is 18 to 8 to 14 mm of the wave band. It can study. So till now, you people are having any doubts related to this one? Till now, if people are having any doubts related to this, till now we discussed about different layers of the atmosphere and solar radiation and agrometeorology observatory related stuff. Having any doubts, we can ask. So I will ask one question. What is the radiation balance between the global radiation and the reflected radiation? Options is diffuse radiation or direct radiation, net radiation, global radiation.
Net radiation.
So then we will study about temperature. The next topic is, like, one weather element is over, that is solar radiation. Then we will go for the next weather element, that is the temperature. What is the temperature? Is the degree of hotness or coldness of any substance is known as the temperature. And temperature, how many instruments are there to study the temperature majorly. That is, a Kelvin scale will be there, and the Fahrenheit is there, and the centigrade is there. Like who given this scale is also important. Like centigrade is given by centigrade, like that almost the scientists are saying. And what is the units? How many units are there in the Fahrenheit? And what is the scale starts from which number and ends with which number?
32 to 212.
212. What is the conversion? It's also very, very important. What is absolute zero temperature is also important. These are the basic bits, and they're asking in the examination. So many people are doing very, very different mistakes. And how this temperature is transferred from the one object to another object. So here we have the three terms, that is a conduction, convection, and the radiation. Is a conduction is nothing but with the help of the molecular activity, the heat will be transferred. Like for example, if you are having any iron rod, so you are heating at a certain end. So other end, like after some time, the heat will be transferred from one end to another end. So this is a conduction process. Like with the molecular activity, this temperature is moving on. Like that is a molecular activity. This is known as the conduction. The convection is a motion in the liquids. That is in the liquid. For example, if you are boiling the water, you can see that the bottom bubbles will comes to the upper area. So it will heat the water. Like in the early when you see that one, the temperature in the bottom side will be more. The water will be boiled, and after that in the above will be boiled. So that is convection. The radiation is without the medium. That temperature will heat will be transferred from one area to another area. That is like from the sun atmosphere to the earth atmosphere, the temperature, the heat is transferring with help of the radiation process. So in conduction as well as the convection, there is a need of the medium is required. But in the radiation, there is no need of the medium for the transfer. Right? That is a basic difference. So the earth will get heated by the, like in the soil will get heated by the, with help of which process it will be heated? A conduction, convection, and the radiation. Within the soil I'm asking, within the soil, what are the basic process? Conduction as well as the convection. Like mostly conduction, but the earth get a temperature with help of the radiation, not with the conduction or convection. So this is the three terms has to know everyone. And why having like how earth get heated is like when earth is having its surface, and when we are getting heat from the sun, so it has to reach to the certain layers, and the conduction process and convection process will be done, and after that earth is heated, then the radiation will occur from the earth surface. So then it feels like a more temperature area. Like when we feel exactly 12 o'clock, sun heat comes to our in the middle of the height, like we will get no shadow in our place in our bottom side. But the air temperature will be maximum in the 2 o'clock, because it will take some time to heat up the atmosphere around the earth surface. Like I told you, that radiation means it has to be reflect the radiation to the backside. So it will take some time. So that's why at the afternoon 2 p.m. you will get the more, feel that more temperature is there. So that's why we will measure the air temperature at 2 o'clock, and that is a maximum temperature. And minimum temperature can be taken at during this time, morning time or evening time.
Morning.
At what time?
6 a.m.
6 a.m. 6 a.m. Correct? Minimum temperature at what time? That is morning 7 o'clock. That is a minimum temperature. And the chemical used in the minimum temperature is alcohol, and this is using mercury. So there is a difference between thermometers where we are using and how we are using also matters. And amount of, like we are getting 100% of solar radiation from the earth surface, and how much of the solar radiation reaches to the earth? 43%. Like for example, if we divide it into the 100, so out of that one, the 43% of the earth energy is reaches to the earth surface, because we have the clouds will be there, we have some ozone layers are there, we have some buildings are there, clouds are there. So some part of the sun will, like sun energy will be reflected into the atmosphere, like it goes back to the atmosphere. So that is around, the reflected radiation is around 35%. And in the atmosphere, the airs, like air gases and everything, they will also absorb the sun radiation. That is around, contributes around 22%. And so the total will be 100%. So here the entire solar radiation coming from the sun is divided into the three types. That is earth atmospheric surface, like earth surface will be abstract something, that is a 43%. And like I will tell you in a simple way, like if sun is giving the energy, and in the top height what will be there? Clouds. So the clouds will take around 35% of the solar energy. So what is the remaining amount? If 100% is there, from that then 35% is taken by the clouds. So what is the remaining? Is 65%. In the 65%, around 22% is taken by the atmosphere. It means the gases or the whatever the nitrogen gas or carbon dioxide or everything, whatever they will absorb, they will also absorb, like those gases also absorb certain amount of the solar radiation. So it is around 22%. So what is the remaining? From 65 to 22 we will deduct. So how much you will get? That is 43%. So this has to be, it will reach the earth surface. So this is a general solar energy. Like for example, 100 calories of the energy is generated from the sun is not going to reach its surface. Its surface is going to take around only 43% of the calories for the heating of the earth surface. So remaining will be in the loss, like they will taken by other things. And like why in the day temperature and night temperature variation will be there? This is known as the diurnal temperature. Means morning, like daytime temperature will be high, nighttime temperature will be low. And why? In the daytime sun will be there, so automatically the temperature in the region will be more, and the night the sun will be not there, automatically it will be cool, but some variation will be there. So that is a diurnal variation. In the seasonal also, in winter you will feel more colder, in the summer you will feel more hotter, because this is because of inclination of the earth, and it is a rotates on its axis at 63 degrees, 66 degrees, like that. Some it will be there. So this variation is known as the seasonal variation. But the diurnal variation is almost very less in the which regions? Diurnal variation, right? The daytime temperature and nighttime temperature is this variation is very lower, like minimal in the which region?
Coastal areas.
But will be the more in the this region is not inland. That is like inland is also a point, but especially in the desert regions. In the daytime temperatures will be high because of the sandy nature, so you will feel more temperatures. But in the night time, because of soil, like sand will get cooled very easily, so you will feel very lower temperature, like Sahara desert as well as these areas. And what is the more amount of seasonal radiations will be? Seasonal variations in the which areas? Higher or lower?
Higher latitude.
Higher latitude means?
More at higher latitude.
Means higher latitude means what? Higher latitude means nothing but polar regions. In the polar regions, what happens is long time you won't get sunlight. So, for example, if you see in the daytime temperature, it will be in the if you get the sunlight, the temperatures will be more. In the night time, you won't get the solar radiation. It will be in the minus peaks. So this variation is more in the higher latitudes. Latitude means the same. And there is no seasonal variation in the equator regions. So till now, having any doubt? Or people having any doubt till now? What is the conversion for centigrade to Fahrenheit? Like how will you convert from centigrade to Fahrenheit?
5/9 C equal to F by 32.
C by 5 is equal to F minus 32 by 9.
Okay. Or else you can directly make C by 100 equal to F minus 32 by 180. That is also like basic one. So if you do cancellations and some that, like if you are having any doubt or like simple also, any problem, like if you are having any confusion also, you can make C by 100. equal to F minus 32 by 180. That's it. Like total number of units on the bottom side, and above is like basic C, F minus 32. Why we have to take F minus 32? Because the thermometer scale in the Fahrenheit starts from the 32, but in centigrade it will start from the 0. So no need to make 0 C minus 0. Automatically it will be C only. But in Fahrenheit it is having F minus 32 because lower degree of the Fahrenheit scale is 32. So minus F minus 32 we will take in the above, right? So that is a basic difference. Like that you can make Kelvin also, like K minus 273 by 546, like that. You can make all the calculations. So till now, having any doubts related to temperature as well as solar radiation? What is the solar constant? I'm valuing watts per meter square per minute.
1353.
1353, yes. And what is the horizontal temperature variation and vertical variation? Horizontal means the place variation. For example, in some places, in horizontal means, for example, in Vizag it will be cooler. In coming to Hyderabad, it will be hotter. Like this is a horizontal variation in the temperature. In the vertical means, for example, in the lower area will be in the lower temperatures. Like in what do you have to say? In the tropospheric region, if you are in like in certain height, we are going by you are going above the land surface, the temperature will be reduced. This variation is known as the vertical temperature. This vertical temperature is having the major effect on the weather elements like condensation or formation of the clouds and it's a form of the precipitation, and these are completely dependent upon the vertical temperature, right? What the term is known as a temperature gradient is temperature decreases as altitude increases. This is a basic one. Is known as the temperature gradient. And what is a lapse rate? The vertical temperature decreases with increase in the height is known as the lapse rate. This is a varies with the place to play. Like there is a normal lapse rate of Earth is 6.5 centigrade per kilometer or 3.5 Fahrenheit per 1000 feet. This is known as the lapse rate. What is adiabatic lapse rate? Is that the decrease in the temperature for increasing the temperature for increasing the height, or because of the air rises or air falls. Sometimes the air will falls and certain times air will above rises. Like with help of wind, when temperature is more, air will get heated and it will go above. This variation is known as the adiabatic lapse rate. So what is the adiabatic lapse rate is around 10 degree per kilometer. So what is the dry adiabatic? That is adiabatic lapse rate, and the normal lapse rate also important. And what is the inversions? But in sometimes what happens is suddenly the inversion has been take place. With increase in the height, the temperature has to reduce. But suddenly with increase in altitude, the temperature also rises. That is inversion. That is a thermal inversion. This thermal inversion is having very peculiar things in the atmosphere. Means what is the basic thing is in thermal inversions is, for example, if you are in a building of around 2 floors, generally in the winter the temperature will be cooler, right? But in the above around 100 meter, what has to be done? The temperature has to be cool, because when you are increasing the height, the temperature has to be fall, right? That is known as the temperature gradient and lapse rate. Like lapse rate is a rate at which it is going to change the temperature in certain height. That is a lapse rate. But temperature gradient has to fall. So this is known as normal thing. But in what happens in the thermal inversion is the lower area will be cooler, but in the upper area above the certain height will be hotter. That is inversion. That is against the thermal gradient concept. Like if people understand, right? So what is the thermal inversion is? It has to, when we are increasing the height, the temperature has to be fall. But suddenly the temperature will also increases with increasing the height. That is a thermal inversion. This concept is a thermal inversion. So what will happen is, because of thermal inversions, the pollution problems will be more, like fog will be formed, especially in the Delhi condition, because of the thermal temperatures, because of any large factories will be there in the city outskirts of the Delhi, as well as any cities having. So they will release, it will release the hot air into the atmosphere with help of the large pipes and like the exhaust, the pipes and everything. They will release the hot air into the atmosphere. So because of the winter and the early mornings of the winters, the lower temperatures prevailing will be in the building areas. So when they will release the hot air into atmosphere, the lower air, the cooler air will trap inside the hot air. So because of this one, the the pollution particles suspends on the atmosphere. So automatically the smoke will form, right? What is the particles are occurring in the fog? Automatically in the winter time, fog occurs on the lower surface of the Earth atmosphere. So these polluted particles are suspended in this air, and it will form such a smoke. And with increasing the temperature, with increasing the duration of the solar radiation, like increasing the time, automatically by morning at 10 o'clock, it will be the pollution will be more. With increasing the time, the pollution level simply drastically falls down, and the entire air from the bottom to the top, it will become the same. So this is a thermal inversion and its impact on the certain weather. Okay, so till now you people are having any doubts? And what is the temperature in, what is the atmospheric temperature without the carbon dioxide? For example, already I told, in the atmosphere certain amount of the solar radiation is taken by the some gases. So in case if we don't have the carbon dioxide in the atmosphere, what is the atmospheric temperature? So I will ask in the options, give option, that will be 25 degrees as a regular. So option A 25 degrees centigrade, B is at 10 degrees centigrade, C minus 16, D 30 degrees. So what will be your answer?
30, sir.
30. So if the carbon dioxide is not there, so your atmospheric temperature will be more, right? You are telling. What is atmospheric temperature generally? (27 degrees). That is a normal atmospheric temperature. But if would have been like carbon dioxide is not there, our temperature has been in the minus would have been there, because the carbon dioxide is having a peculiar character that it will absorb the most amount of the solar radiation. So that is known as the greenhouse effect, right? If people know about greenhouse effect, because nothing but the solar radiation comes to the energy, but some of the reflected radiation is taken by the atmospheric gases in the atmosphere, so it will heat the atmosphere. So that is a greenhouse effect. So nowadays we get increasing the carbon dioxide levels in the atmosphere, the temperature of the earth is increasing. So that's why we are feeling more amount of the temperature in the area. In the long days back, our normal temperature would have been the normal, but now because of the more carbon dioxide concentration in the atmosphere, the temperature of the atmosphere is increasing gradually. So we are feeling more hot than the previous days. So that is greenhouse effect. So the same effect or same technology we are using in the greenhouses. So that's why there is a greenhouse, right? So what is the concentration of the carbon dioxide in the atmosphere? Is a regular, like in the 19th century, and what is now? In ppm, what is the carbon dioxide concentration in the atmosphere is? Now it is in the 430 ppm or 410 to 430 ppm, but actually it should be in the 330 ppm because of our industrialization and our carbon dioxide levels in the atmosphere is increasing. So our earth temperature is also increasing day by day. So this is known as the global, that is greenhouse effect. And then coming to the soil temperature. Because, as I told, with help of the conduction process, the soil gets heated, right? So here we have the instrument called soil thermometer to measure the soil temperature. So here the soil temperature is having different, it varies with the soil to soil, because that is a because the conductivity will be different. Means the rate of heat entered into the soil is it depends upon the different factors, that is a porosity or presence of the organic matter or presence of clay layers. So that will be changes. So this is known as the thermal conductivity. Conductivity is nothing but how it is conducts the temperature into the soil, like how it is allowing. Like as I told, conduction is a molecular activity. For example, the basic above layer is getting heated. After that, the next layer will be at out. Like top 5 centimeters are heated due to the solar radiation for in the daytime. After that, the next 6 centimeter, 7 centimeter, 8 centimeter will be heated because of the conduction process. So this process, this capacity is known as this phenomenon is known as the thermal conductivity. So this thermal conductivity varies with the soil to soil with help of with the different parameters with effects on the soil organic matter. Because when if soil organic matter is there, it will the conductivity will be slower. So the soil temperature will take longer time to penetrate into the like it increases soil temperature. It will take longer time. If you are having moisture also, it will take a slower. Like it will take some time. And if your soil is having the micropores, the directly it will go into the deeper layers. So in this way, the soil temperature is varies with the soil to soil with the different factors. When if we are plowed the soil, porosity will be increases and it reduces the conductivity of the soil. So it will take longer time to reach the um, lower layers. So this is known as the thermal conductivity, and this relation between the thermal conductivity and the soil temperature is very more important. They are asking different questions in the examination, so you people has to know. And what is the effect of this soil temperature up to how many centimeters is having is a broader effect. It is around 80 centimeters, means around uh, 3 feet, not 3 feet, around 3 feet, it will be having the effect on the soil temperature. If you dig, like, if you know when we are digging the soil, like if you with the help of the crowbar, you are digging the soil, you feel the heat. Like the top layer will be okay, like it will be hot. When you are digging more and more, you will get heat. Okay, that will be different. But I'm telling up to 80 centimeters, you will feel okay. We are getting some moisture will be there inside. You will feel some coolness is there in the soil. So this the soil temperature gradient is up to 80 to 90 centimeter. That is up to 3 feet will be this variation is there. So this is all about the soil temperature. So till now you people are understood, right? And soil temperature is having how we will measure soil temperature with help of soil thermometer, as I told, but it is having the bend, like it has to be intact with the soil. So then only you will get to know about what is the soil temperature. But here what happens is U-shaped bend will be there. So we will insert the thermometer entirely inside the soil, but only the reading part should be in the visible to the outer like above the soil. So with the help of this above soil, you can measure the soil temperature. Like as I told, maximum thermometer, minimum thermometer, soil temperature, and thermocouples is also there. You can measure the soil temperature as well as the air temperature with help of thermocouples. So, and we have one more thing, that is a thermograph is also there. You can make it will make the temperature over a 24 hours of time in a clockwise direction. It will make the temperature, like it will make a graph. This is known as the thermograph. Okay, the sheet of paper. It will give the entire 24 hours duration and it's your temperature and everything it will give. This is known as thermograph. And what is the lines which are drawn with the similar temperatures over a area is known as the isotherms, right? So till now, you having any doubts, you people can ask. So what we today discussed about is agrometeorology and its definition, and what is the climate, what is the weather, and what is the significance of agroclimatology to productivity of the crops, and how the agrometeorology influences the yield, and what is atmosphere. What is atmosphere? Atmosphere is nothing but air, and what is the different layers of the atmosphere, and how it will be differentiated, and what will happen with these layers, and what is agro observatory, and when IMD started, and what are the different types of agro observatories, and where we will have which type of ABCDE or observatories are there, and how we will measure, and what are the instruments are there, and how will you arrange them, and with what height you will mention, like you will keep these observations, like how will you take these observations, and then what are the weather elements which are affecting the crop productivity we taken, out of which we completed solar radiation. In solar radiation again we seen what is solar radiation, and what is the solar constant, and their units in a different things, and what is Einstein, what is net radiation, diffuse radiation, global radiation, total incoming radiation, and what is out of which what is amount of radiation is useful for photosynthesis activity. So like this, we studied around solar radiation, and then coming to the temperature studies, how the temperature will uh, process, like heat transfer will occur, temperature transfer. That is also we studied. Like that is conduction, convection, as well as a radiation process, and what is the seasonal variation temperature and the diurnal variation temperature, how it will vary with the season to season, how it will vary with the zone to zone, and like we studied all those things. And what is lapse rate, adiabatic lapse rate, and thermal inversions, and we studied like thermal inversion we studied, what is the soil temperature, how it will measures, what is the variation in the soil temperature, what how the thermal conductivity is impacted by the soils, like what are the reasons behind the thermal conductivity, how it will vary with the soil to soil, what are the reasons, we studied till now. So this is the class for the today. So if you are having any doubts, so as I told, you can ask any doubt. So, other people are having any doubt, or is it okay? Madhavi?
No doubt, sir.
No doubt, sir.
Okay then. So, can I ask some questions from agrometeorology related works?
Yes, sir.
Yes, sir.
Okay. I'll ask very general questions. Okay. Wait. Like which radiation can we
సార్
use?
వాయిస్ స్లోగా కనపడుతుంది సార్.
Slow వినిపిస్తుందా?
ఎస్ సార్.
సో ఓకే, ఏ రేడియేషన్, లైక్ విచ్ రేడియేషన్? సో అక్కడ ఉన్న వాళ్ళందరూ తెలుగు వచ్చు కదా ఆల్మోస్ట్ అందరికి. ఓకే రైట్. విచ్ రేడియేషన్ we will use in the like precision agriculture? Like not precision agriculture means high-tech agriculture. Which type of radiation we will take into consideration? A, solar radiation, like solar radiation. B, reflected radiation. C, direct radiation, like that. Which radiation we will take into consideration for precision studies or remote sensing studies? Okay, that is a cool. Remote sensing studies. Which type of radiation we will take into consideration? Which type of radiation taken into the consideration for studies of remote sensing? Option A, diffuse radiation. Option B, net radiation. Option C, reflected radiation. Option D, none of the above. Which radiation we will take into consideration? That is reflected radiation. Reflected radiation. And when we will measure the maximum temperature?
Afternoon 2 o'clock.
And what is your range of thermometer for maximum temperature?
Sir,
Maximum like I don't know, like maximum thermometer and minimum thermometer will be there. What is the range of the maximum thermometer? Range, scale, no? Like I have, like for example, if you are having zero, like
Sir, voice not clarity, sir.
okay. ఇప్పుడు వినిపిస్తుందా క్లారిటీ?
Some disturbance, sir. Air distance.
Okay, now it's okay. So ఇప్పుడు like a centigrade scale means 0 to 100 is there. Fahrenheit means 30 to 1, like 2 to 2 to 1 is there. Like that, what is the range of the maximum thermometer? Is minus 35 to plus 55. Minus 35 to 55 scale. It is a scale. Temperature range is minus 35 to 55. So totally is how much? 35 plus 40, 55. So 90. So 90. That is a range of the thermometer can measure around 90 degrees variation. It can be measured. So minimum temperature is like minus 42 plus 50. So this is also 90. So here you can remember that maximum is from minus 35 to plus 55, but minimum is minus 40 to plus 50. So these ranges are very, very important, and at what time you are taking considerations also important. And what is the temperature range of dry bulb? Range is same, 35 to minus 35 to plus 55. And how will you place them? Wet bulb is in a horizontal or vertical? Dry,
Vertical, sir.
huh? How will you keep? Maximum and minimum temperatures in the horizontal. Dry and wet in the vertical. Okay.
Yes, sir.
Wet and dry in the vertical position will keep. Horizontal is maximum minimum temperatures. And why will you keep wet and dry in that direction is because it has to take the evaporation studies. Like it has to evaporate something. So then you have to keep them in a vertical way. But the maximum minimum temperatures are in the horizontal. And these 4 thermometers will keep in the Stevenson screen. And what is the height of the Stevenson screen from the land surface? Like what is the height should be there?
1.22 meters.
That is like these are the basic bits. Like you don't know like how they will ask also, you don't know. They will ask in JRF examination, they will ask very, very silly questions. Like you will feel they will ask like very simple. You will feel that why they are asking this type of silly question. One time they asked, what is a majorly used nitrogen fertilizer? What is a majorly used nitrogen fertilizer in India?
Urea.
Urea, sir.
Urea. And what is the cheapest fertilizer in India? Like what is the cheapest nitrogen fertilizer? Cheapest. What is the cheapest nitrogen fertilizer? Anhydrous ammonia. And what is a okay? So okay, this is for all today. If people are having any problems, like if my voice is faster or slower or any problems, you can tell. Okay, no problem with my voice.
No, sir.
Okay, audible to everyone.
Yes, sir.
So you people are preparing for JRF from the first year itself.
Sir.
Oh, great. So if people are having any problems, you can ask now. So yeah, if people are not having any problems, and we can close the class for today, and we can meet on Friday.
Thank you, sir.
Okay, then I'm wrapping today itself here. Okay then. Thank you all for your kind
Thank you,
presence.
sir.
Sir, when will be your next class, sir?
Thank you.
My next class is in Friday,
Okay, sir. Okay, sir. Thank you,
and
sir.
like if you having any doubt, okay, not for you people, it's only for the final years I can help now, but not for the. Chalo. Okay, thanks for your patience and everything. Chalo then. Bye.